And as usual, what I want to do is bring us back to the course schedule here, which is at the back of the syllabus. So today is Tuesday, the 2nd of February. This morning we're going to finish up the final segment of Chapter 1, where we're wrapping up the segment on research methods. When we get together online on Thursday, we move into the bio chapter. Let me tell you this to get you motivated for the bio chapter. The bio chapter, when test 1 rolls around, which is 2 weeks from today, will probably be about half of the 40 questions. Okay? So we're only covering 2 chapters, and basically the breakdown is about a quarter of the questions will come from the intro and different theories in psychology and the history of psych and the subfields that we talked about last time face-to-face. A quarter will come from this research method segment that we're finishing up this morning, but the heavy lifting will really be in the bio section. Okay, so we'll do bio online Thursday, part 2 in here together next Tuesday, and then we'll finish the bio section on Thursday online as well. Again, I want to recommend that you guys make use of supplemental instruction. So remember, we talked about this last week, and the SI leaders all introduced themselves. This is the schedule for the week. So Haley is up next today at noon. She's actually here up front. She can wave her hand around. Shyla and Harrison are also running sessions today, and then you can see the rest of the scheduled sessions for the week. It would be a good idea to get in there and start working on this stuff with them now rather than later. Okay? Any questions about that or any other housekeeping questions about anything? Are those questions, or are you waving to a friend? Questions? You're going to have to talk really loudly. Turn up the volume a little bit. I'm not loud enough? Okay. I will do that. Ironically, I couldn't hear her, and she couldn't hear me. All right, so let me crank it up a little bit here. And I still hear a fair amount of chatter, so if you guys could settle in, that would be good. Is that better now? Is that a yes, or you still can't hear me? Are we good now? We're good? Still higher? Wow, okay. I don't want to blast anybody out of here. How's that? Is that better? Here's what the issue is. Do you hear all the mumbling? So if the mumbling stops, I'm going to be really loud and clear. Hey, the mumbling stopped. Are we good now? Okay, good. So I want to begin this morning, as I typically do, by circling back to some of the big ideas from what we did online on Thursday. Before I get into this, let me tell you that when we start in here face-to-face on Tuesday, what am I assuming you've done? I'm assuming that either you were there live on Thursday online, or sometime after that you viewed the recording. So if you are here now and you don't know anything about the research designs that we were talking about online on Thursday, you're going to be stuck. Okay? Because what will happen is typically I'll ask a couple of clicker questions that are contingent on having viewed that session. So I'm just assuming that, like, if we had a face-to-face class on Thursday, you would have been there. I'm assuming that you did the same thing with the online session. So here is the advanced organizer that I talked about on Thursday. It's a nice way when you have a bunch of novices to a discipline, like you guys, that is newbies to psychology, I'm assuming. It gives you a nice roadmap for what we're going to do. So we've been talking about research designs. We did that on Thursday. We're going to finish that up this morning talking about experimental designs. We'll talk about measurement approaches this morning, and we're really going to emphasize reliability and validity, because it's important here as a foundation for the rest of the course, but it's also important as we go forward and talk about intelligence assessment and IQ testing and measuring personality and assessing different psychological disorders. So these are 2 key concepts that come back another 3 or 4 times as we go forward. We'll talk about data collection techniques. So if you're a scientific psychologist, how do you gather the data that are in your study? It's not just going to be, by the way, have people do some kind of online survey and that's your study. That's a lazy approach to data collection. And then we'll talk about some statistics, and as I promised last week, it won't be any more complicated than my 5th grader did back in like 2nd grade. Means and medians and modes. one little brief segment about ranges and standard deviations, and no computations at all. Okay, but we will wrap up the final 8 or 10 minutes by talking about some statistics. So I'm going to hit a couple of the big ideas from last time. This slide is the one that at this point you should be able to explain to your niece or nephew, your roommate, your neighbor, your coworker. If they don't know anything about descriptive correlational experimental research, you should be able to spell these out in a way that it will help them understand what this is about. If you could do it via examples, that would be great. So you should be able to say, descriptive research just describes something, right? So when I do a survey of opinions about political issues, that's a descriptive research study. If I do observations of people in the real world environment, maybe I'm an education researcher and I sit in the back corner here and I observe students in a large lecture class like this. That's naturalistic observation. Again, we're just describing, we're not manipulating, we're not controlling. I get nothing about cause and effect here with descriptive research. With correlational research, what are we looking for? Somebody tell me in your own words. Correlational research looks for what? Relationships, right? Associations. Are these things connected? Like, is there a connection between the number of hours that I study and my grade in the course? So as on the x-axis here, I'll do it this way, right? As the number of hours of studying goes up, does my course grade go up? Is there some kind of an association, some kind of a connection like that? We talked about the caveat regarding correlation doesn't mean causation. We'll circle back to that in a minute. We really tried to play up experimental research. We said when it's ethical to do so, it's the best research design because it will illuminate cause and effect relationships between variables. And the reason that matters is that all science is about testing out theories, and theories are statements about causal relationships between variables, right? So ultimately, if you want to advance a science, you want to test out theories, and to test out theories, you want to get at cause and effect, and to get at cause and effect, you have to do experiments, okay? Best way to do it. We talked a lot about correlation coefficients. You need to be able to interpret a correlation coefficient. So if you're given a correlation coefficient of negative 0.75 and another one that's positive 0.26, you have to be able to say, what the hell does that mean, right? Which one is stronger? Well, ironically enough, the negative 0.75 is stronger because to find the strength, we said we look at the number. We cover the positive or negative sign. We look just at the number. The bigger the number, the stronger the correlation. So technically, negative 0.75 is a stronger relationship between those two variables than a correlation of positive 0.26. Okay. What was the caveat about the size of the number? It can't be bigger than what? It can't be bigger than 1. Okay. So I like to give you a question where I say, find the strongest correlation coefficient among these 4. So in 2 weeks, you should cover the positive or negative sign, find the biggest number, again with a warning, it can't be bigger than 1. Okay. Direction is indicated by the positive or negative sign. This was when I was online, when I was doing the thumbs up, or thumbs up, thumbs down thing for positive and negative correlations, right? So positive correlations are situations where as we get more of X, we get more of Y. The more hours that you study, generally speaking, the higher your grade in the course, although it's definitely not linear. It's not like this, right? It's not a positive 1.0 correlation. Right? Because I have tons of students over the years who come to office hours and say, well, I studied a whole lot of hours and I didn't get a high grade. How is that possible? It's supposed to look like this. Well, my first question is, what did you do during all those hours? Because it's not like clocking in at work and then clocking out, right? It matters what you did during that time. So we won't always get those positive correlations approaching 1 necessarily for all these scenarios. But positive means that situation where they go up together, they go down together. Negative correlation means as we get more of X, we get less of Y. Okay? As you spend more and more time watching TV, or I guess now Netflix, what happens with your grades? They're generally going to go down, right? Okay? As I spend fewer hours watching, I tend to get higher grades. Okay. The example we did online on Thursday was temperature and hot chocolate sales. As temperature goes up, hot chocolate sales go down. As temperatures go down, hot chocolate sales go up. So when we're taking the test in 2 weeks and I give you one of these questions about positive versus negative, you could sit there and do this all day long. I don't care. I'll know what you're doing. I'll know you're not flashing gang signs or something or trying to cheat. Okay? So questions about correlations like that. Does that make sense? So make sure you're able to interpret these. It's important. All right. The final segment was on experiments in a second. Let me remind you about why correlation doesn't mean causation. There are 2 reasons why. The first reason is because of directionality. We find that X is associated with Y. Do we know that X is causing Y? No, it could be actually that Y is causing X. Because we're not manipulating any variables, we don't know which way to draw the arrows. Okay? In an experiment where we manipulate caffeine intake and we look at its impact on reaction time, we know that the arrow goes from caffeine intake to reaction time. It doesn't make any sense to say, well, your reaction time affects how much caffeine you drink. No, that doesn't make any sense. Because temporally what we did was we manipulated this first and you got caffeine or you didn't, and then we measured your reaction time. Okay? So directionality is an issue. The bigger issue really, I think, more often is third variables. We said these were also known as confounds. I mentioned on Thursday about the multivariate world idea, that almost everything that we talk about in psychology is interesting because it's not a discipline where A causes B, and like that's the whole story. Bye, we're done, right? Behavior is determined by so many different variables that we should always be thinking about what other factors might there be, right? That's one of the reasons why that biopsychosocial model is so great, because it makes you think about numerous different factors and not just one and only one variable. So for these 2 reasons, we know that correlation doesn't mean causation. Okay? We talked about that. And we finished up with this slide and the next one talking about experiments. What I slipped in here was that in step 0, on occasion, not always, but sometimes, there is random sampling. So to understand the difference between random sampling and random assignment, if you guys are the population that I want to study, random sampling is when I use a random procedure to draw, let's say, 50 of you to come up front and be participants in my study. So random sampling is how you pull the sample from the population. And then random assignment is, now I've got 50 people up here, and I'm going to randomly assign them to either drink coffee with caffeine in it or drink coffee that's decaf. Okay? I flip a coin. Heads, you're in that group. Tails, you're in that group. Okay? I use a random procedure to then assign you to those 2 different conditions. Now I'm manipulating an independent variable. In this study that I'm describing, I'm manipulating, easy for me to say, your caffeine intake. So however many milligrams versus 0, okay, for regular coffee versus decaf. And then I'm going to measure the effect of that manipulation on my dependent variable. So on this next slide, we talked about the fact that the dependent variable supposedly depends on what you got with respect to the independent variable. So we think reaction time, or maybe as our dependent variable, we measure memory performance. We think those dependent variables depend on whether you had caffeine or not. Okay? And so that's a typical design. You need to be able to recognize IVs and DVs, and I'm going to give you a clicker question here in a minute that will let you practice this. Okay? Questions on any of that at all? How many of you guys have heard a lot of this stuff before about experiments, IVs and DVs and all that stuff? I hope it's more than that. I hope some of you are just being shy and not raising your hand. I would expect by this point in your academic career you should have been exposed to a bunch of this stuff. So we're going to begin with this as our first clicker question. So let me make it full screen for us. Here's the question. If university graduates, stop warning me about that. If university graduates typically earn more than high school graduates, this would indicate that level of education and income are what? Are they positively correlated? Are they independent variables? Are they dependent variables? Or are they negatively correlated? University graduates earn more than high school graduates. What's going on there in terms of the variables of level of education and income? And if you think you've gotten it right, think about for a second what third variables might matter. If those are the only two things that you measure, what else might be playing a role here as you look at these variables? Okay, it's a nice way to sort of expand on the question here and see how you can tie it into other concepts we've talked about. 445 people, that's unbelievable. Let's see. Oh, this is really good. See that? Did you guys notice that that's new? My SI leaders, how it pops up now? It's like a live rolling into the results. It's exciting for me. You guys don't care, obviously. But let me give you the lime green bar for the correct answer there. So these are positively correlated. What would be going on with my thumbs if I was doing this during the test with the thumbs? I'd be going what? Years of education, as that goes up, what happens with income? It goes up. Or as years of education go down, generally speaking, income levels go down. Does that mean that everybody who has lots of education is making tons of money? Not necessarily. Does that mean there's no one who has really low levels of education who's making a gazillion bucks? No, we've got those too, right? So it's not a perfect correlation of positive 1.0, but this is probably going to be a relatively strong positive correlation. If you made me guess, it's probably 0.6, 0.7, positive 0.6, positive 0.7, something like that, between education and income. Questions on that at all? When we're 80% plus, I think you guys have got it, so I continue on. This one I really like. I know it's right from an old test. So read it and try to identify the independent variable. And then we'll talk about it. I can smell the wood burning. You guys are thinking about this one. That's good. If you think you've gotten it right, now look at it and try to choose which one of those might be the dependent variable. It's a nice way to use the question for a couple of concepts. All right, last couple of seconds. What happened here? Oh, that's good too. So I need somebody to explain to me in your own words why the amount of alcohol consumed is the independent variable. How did you get there?
Because I was taught in high school that independent variables, like IE stands for eye control, and it says like variable choosing level 4 to 0
Okay, so she said when she learned this stuff in high school, when she learned independent variables, they told her to remember I control, a little mnemonic for this, right? I control it, and so what I'm controlling is whether you're going to get 4, 2, or 0 ounces of alcohol, right? Okay, that's a great explanation, right? The independent variable. What's the dependent variable here? A, B, or D? B, right? It says right in the question, he's testing the physical coordination skills of 21-year-old men. So he thinks that alcohol consumption has an impact on physical coordination skills, right? And my mnemonic for you guys about dependent variables is to say the dependent variable depends on what you got with your independent variable, right? So your physical coordination skills depend on how much alcohol did you have, 4, 2, or 0 ounces. Okay? Any questions on that setup? It's right from an old test, okay? So if you can handle that sort of thing as we're going through this, and when you're practicing doing questions and learning curve and all that, you're going to be in good shape. By the way, let me sneak in a little bit of ethics here. Notice that we're running this study with alcohol consumption with 21-year-old men. Now, the 21-year-old part, why we're doing that is obvious, okay? You can't run a research study here where you're getting 18-year-olds hammered. That's not going to work out well. Okay? Why just men? Why are women not enrolled in this study in terms of the ethics of the research that's being done here? Is there a concern if we enroll women in the study? Potentially for some control or be able to say something maybe specifically about men, but there's an ethical reason why we don't want young women coming in and being given alcohol. They could be pregnant, okay? And so if we wanted to run this study with women, one of our procedures would have to be what? As the women came into the study, what would they have to do? Take a pregnancy test. Like that's like the first thing you want to do, right? I signed up for the study on Sona, and the first thing they did was give me a pregnancy test. That was fun. I want to do that again, right? So the reason why, obviously, is that if we give alcohol to women who are pregnant, then we could get into big trouble if there are consequences down the line. It reminds me of when I was in grad school. I was up at USC, and we were in that, if you know USC's campus at all, we were in the 10-story Sealy G Mudd building. We were on the 9th floor, and once a week on like Tuesday nights, I think it was, the guy who did alcohol research in the psych department would have this stream of 21-year-old guys going up to the 10th floor, which always made me really nervous. Like, we're getting a bunch of 21-year-old guys drunk on the 10th floor of this building. But the windows were all sealed, so we didn't have to worry about anybody flying out the window. But it was always just guys because of that issue regarding pregnancy and pregnancy tests. So, any other questions about that? You can make your own test items. I know this is one of the things you guys do in supplemental instruction sometimes. Create your own little experiment and define what's going on, and then have somebody try to identify independent variables and dependent variables. It's good stuff to do. All right, so we're going to explain now the different groups that are part of an experimental research design, and we're going to use the example of a treatment outcome study for folks with major depression. So we have an experimental group that is subjected to the independent variable. That is, they're given the treatment in this treatment outcome study. So one group might be, if we want to run with a talk psychotherapy example, a CBT, or cognitive behavioral treatment group for depression. This is just a group where you come in and you use as your model this thing that we talked about back on day one: thoughts, feelings, and behaviors as factors that mutually influence each other. And we use this as a way to generate tools and strategies and skills for managing depression. So for example, in the cognitive behavioral treatment group, we might have you learn how to identify and change negative thoughts that are making you feel depressed. Or we might have you engage in more pleasant activities in this behavior part of the triangle, because doing those things might make you feel less depressed. So that might be your group. Let's say the CBT group meets twice a week, Tuesday and Thursday, from 2 to 3:30 at this clinic. Fantastic. Okay. Or if you don't like the talk therapy example, I built in a second example on the side that is focused on medications. You're running a study where you're trying out a new antidepressant medication that Pfizer has put together. They're one of the big pharmaceutical companies. Here's a picture of the pill that they're going to use. It's yellow, not blue. And the pill actually has a smiley face on it. And the name of the new medication it's called Happy Times. You guys have now heard Happy Times 3 times. I'm really sorry. It's the same damn examples and even some of the same jokes. So we've got this Happy Times pill, and we're going to try out to see whether it works. So let's pretend in either scenario, in talk therapy or the medication trial, we get a bunch of people who are depressed. We assess their level of depression. We identify them as being appropriate for this treatment. And what we do is we give them the CBT talk therapy for 6 months, or we have them on the medication for 6 months. And then what we do is post-treatment, right after treatment, at the end of 6 months of treatment, and then another 6 months post-treatment, and then another 12 months after that, we have them come in. So now we're talking, a couple of years out even, potentially. And lo and behold, what happens is at those different follow-up times, what we find is the people who were this depressed before and either came into the talk therapy example, or if you like the medication example better, they're a lot less depressed than they were. That's awesome, right? So the treatment must work, because people who were really depressed, now 6, 12, 18, maybe even 24 months later, they're a lot less depressed. So the treatment works. I'm glad I'm going to make $1 million from this new pill. I have all these stock options with Pfizer. It's going to be awesome. Okay? Are we certain that the treatment is what caused the change? Let me ask it this way. Is it possible that the treatment caused these folks to be less depressed? Is that possible? Yes, it's certainly possible. So you want to nod this way. Yes. Okay? Do we know for sure that the treatment is what caused the depression to drop? And you're going to shake your head this way, like a lot of you are doing. Why are we not sure? I mean, you were sad, and I treated you, and now you're less sad. It's got to be the treatment. Talk to me. Yeah.
Over the course of the 6, 12, 18, 24 months, something could happen, like somebody could have been depressed because they were lonely, and someone entered their life.
Awesome. Okay, so one potential, what you're describing is what? Third variable, right? A confound is the supposedly treatment-induced decrease in depression might actually be due to I have more and better friends than I had before. So I make new friends. So now I'm going to open up and ask you guys, what else could have happened that led to things being better in terms of your mood? Could have been a placebo effect. We'll get into that in a bit, so hold that. What else could have happened? Tell me good things or bad things that could have changed that made you feel better. Huh? I got good grades. Okay? You're going to grades. Usually, you guys, because you're all poor, you guys usually say, I got more money. Right? It's usually like, I get more friends and I get more money. Okay? Let's go right to the things that really matter. Anything else that could have happened? Yeah. The economic situation in the country improved, and maybe that has an impact on a number of different other variables. So lots of different things. Your dog that you thought was dead is actually still alive. Okay? So the point is, good things like getting more friends could have occurred, and bad things could have gone away, right? Somebody in the 8 o'clock section, like typically happens, said, you got rid of that boyfriend or girlfriend who was horrible. Right? That's like addition by subtraction. Right? You're improving your mood because of any of a variety of these different third variables. So, what do we need to account for those things so that we can make sure that it's the treatment that's doing the improvement in my mood? What do we need is what? We need a control group, right? So let's get ourselves a control group. A control group is a group that is similar in every way to the experimental group, except for that IV manipulation. And I'm going to underline the phrase, similar in every way. This is worth a gazillion bonus points. What procedure makes my control group similar in every way to my experimental group? What do we use? Random assignment. You win the 1,000,000,000 points. That's 2 good answers in one day. You can now take a nap. All right. So random assignment is the thing. It's the magic bullet that will make it so that now I've got a treatment group. Follow along here. I'm going to track this over time, right? A treatment group and a control group. These guys get the medication or they get the talk psychotherapy over time. These guys in the control group are similar in every way, and they go through life over the 6, 12, 18, 24-month period of time that we're talking about. And you know what happens in both groups? All the things you mentioned, right? You get more friends, you're making more money, you get rid of the crazy boyfriend or girlfriend, your dog comes back, the economy gets better. All these different things are happening across both groups. So now we can cross those off. We can eliminate those as explanations for the decrease in depression. And effectively what we're doing is saying, well, it's not all of those things. What are we left with? It must be the treatment, right? It's like playing detective here. We're trying to get rid of all the other possible explanations and say, you know what led to the treatment-induced change? The treatment. It wasn't all those other possible third variables or confounds. It was the treatment itself, whether it was the talk therapy or the medication. Okay? Typically, the control group in this kind of treatment outcome study will come in the form of an untreated waitlist control group. Let's unpack that. Untreated means, well, we don't treat them. Waitlist means we tell them you're appropriate for this depression treatment outcome study, but unfortunately right now all of our treatment groups are full. We have a maximum capacity for those. So you're going to be on the wait list. And what we're going to do for you is we're going to call you each week and talk to you on the phone for about 10 or 15 minutes to assess your level of depression so that we can track that over time. Okay? So think about it now. The difference is here. Let's run with the CBT example to compare it to this untreated waitlist control group, right? It's probably the best way to compare these two. The folks in the CBT group are getting 2 hours a week, Tuesday and Thursday, 2 to 3:30 we said, right? 2.5 hours a week of treatment by a mental health professional at this clinic. These guys are getting a 15-minute phone call and no treatment. Okay? There are two reasons why this untreated waitlist control group is not perfect for us. One is really about a research issue, and one is actually about an ethical issue, yet again. Okay? On the research end of things, what I get worried about with the untreated waitlist control group is that we want to manipulate treatment so that it's treatment versus no treatment, and that's the only difference. But in how I've described these two, what else is different between the CBT group up above and the waitlist control group down below? Is there anything else that's different between them? What did I say about time? Yeah. Yeah, the amount of time you're talking to somebody. These guys are getting an hour and a half twice a week. They're getting 3 hours of face-to-face interaction. And what did I say these guys were getting? 10 or 15-minute phone call. Okay? So it's not just treatment and no treatment. It's treatment plus 3 hours of FaceTime versus... And now, when you have those really two different things being manipulated, treatment versus no treatment, and 3 hours versus a 10 or 15-minute phone call, you've got a confound, right? Because now on the back end, when there's a reduction in depression for the treatment group, you're like, well, that's good, but I don't know it's because I treated them or because they had 3 hours of face-to-face time versus a 10 or 15-minute phone call each week. Does that make sense? So it's not perfect in that regard because there are research issues that are raised. On the ethical side of things, are you worried at all about a group of people who have major depression who are not getting treated and who are told they're in the wait list and they should just kind of sit and hold on for a second? It's like flying standby. Are you worried about having a bunch of depressed people just kind of sitting there? And if so, why are you worried? You should be saying, yes, I'm worried. Now you need to think of a reason why you should be worried about a bunch of people with depression who are not getting help. What might happen? Yeah. They could be getting worse in their depression. I mean, you can imagine, like, again, not to keep picking on Eeyore and Charlie Brown, right? But Eeyore and Charlie Brown were like, oh, man, right? Charlie Brown was like, I suck so much, I can't even get in the treatment group. That's how bad my life is and how horrible things are going right now. But more specifically, and not in a joking way, what's one of the symptoms of depression that would potentially be life-threatening here? Suicidality, right? So now I've got people who could potentially get suicidal, and all I'm doing is I'm calling with a 10 or 15-minute check-in on the phone each week. Oh, that doesn't sound so good, right? Because if they kill themselves, that's bad in a number of ways, right? So we might need something else. We'll talk about what that something else is now. We might need a placebo control group, and here's the deal. It's a special type of control group that doesn't have a treatment that includes any kind of active ingredient. The fancy word here is you try to give a treatment that is inert. You probably learned that somewhere along the lines in some kind of science class, right? An inert substance is, it just kind of is like nothing. Nothing's happening there, right? So in the medication trial, that would probably be a sugar pill. And we're going to get to your placebo effect comment in just a bit here, okay? In the medication trial, we might give you a sugar pill, and this would be compared to the real pill. And that sugar pill, by the way, should look exactly the same. So yellow and a happy face on it. For the treatment, that's the talk therapy, cognitive behavioral treatment, here's the deal. I'm going to offer these folks now not nothing, or not just a phone call for 10 or 15 minutes. I'm going to offer them a supportive group therapy. And here's how we make the FaceTime and the person-to-person interaction equivalent. They come in to the clinic Tuesday and Thursday, let's say, 12 to 1:30, and they're in a group, but the group is not a treatment. It's just supportive group therapy. And this is where it gets weird. To make this inert, what you need to do as the psychologist running the group is not talk about thoughts, feelings, and behaviors. Don't give them strategies for identifying and changing their thoughts. Don't recommend that they do pleasant activities. So, I mean, if I was running this group, I would literally have to sit on my hands, because when I'm running the groups, I want to get up at the board and track things and write numbers and draw pictures and all this. And I would just be sitting there in the supportive group therapy, inert treatment group, and I would just be being nice to them. So it would be like something like, hey, how about those Chargers? Hey, you think they're going to leave or not? And we're talking about things, and we're being nice, and we're being supportive, but we don't go down that road of like, well, here's what you should do. You should challenge these negative thoughts that you keep having in these different situations. Oh, and here's a chapter of this book that you could read that will be helpful for what we've been talking about this week. No, none of that. Just be nice to them. Talk about the weather. Talk about whatever. But don't go down the route of trying to offer things that would actually help them. Okay? For the medication example, the sugar pill, again, is the inert treatment. So it looks just like the other pill, same color and everything, except this one has the chemical, and the sugar pill, the placebo, does not. Okay? Think about what that makes equivalent. So when I have a group that comes in up top and gets the real medication, and I have this placebo group down the bottom that comes in and gets the placebo pill, everything is equal other than medication or a chemical up top versus not down the bottom. Because both groups are doing what with the pill? Swallowing the pill. And both groups are thinking what? Might be thinking like, this could help me. Okay? The only difference is chemical versus not. And that expectation is the placebo effect thing you were asking about before. In fact, if you wanted to get really fancy, the way you could actually quantify the bump that you get in just thinking that something is going to work is by having this as a third group in your study. So medication, placebo pill, weightless control group. And if you compare the weightless control group to these guys, neither one of those groups is getting any chemicals, right? What is the bottom group getting that they're not getting? The pill, and what are they getting in terms of the thinking? The expectation that it's probably going to help me. So if you want to quantify, like, how much decrease in depression do you get just from thinking that the pill is going to help you, you could actually quantify it by doing that comparison. That's more than you need to know, but just in case you're curious. Okay? Any questions about how or why we do this design this way? I got one final thing to mention before we wrap this up. Have you ever heard of a double-blind design as part of this kind of clinical trial or this treatment outcome study? Can somebody explain to me what double-blind means? Do we run around and poke everybody in the eyes? No. What does it mean?
It's when both the evaluator and the people being treated do not know.
Okay.
They're not.
So both the researcher slash evaluator slash nurse or doctor, both the researcher and the participants don't know who's getting the real medication versus who's getting the placebo. Another way to say it would be neither the researchers nor the participants know who's getting the real medication and who's getting the placebo. Okay? Now, obviously, you know what I'm going to say next, right? Obviously, somebody somewhere has to know, right? You can't get done the study and be like, oh, shit. Well, nobody knew, so that's good. It's double blind. But somebody's got to be tracking it, right? Because we need to have, like, here are the numbers for the people getting the real medication. Here are the people who got that fake pill. And, oh, look, the numbers decrease more there than they did with the fake pill. Does that make sense? So somebody on the study who probably doesn't interact with the clinicians or the researchers or the patients themselves is in control of that, but yeah, you need to have that in place. So why don't we want the doctors who are running the groups or the nurses who are maybe dispensing the pills, why don't we want them to know who's getting the real medication or not?
Maybe they want the medication to work so they can change the result.
So they might be biased in some way. Maybe they want it to work because they've got like all this Pfizer stock in their retirement account, right? And if this pill works, they're going to make $1 gazillion. And maybe in a not so subtle way, when they hand out the medications, they might be like, well, here you go. You got the good medication. Sorry. Well, you got the placebo. And now I'm changing their expectations, right, by doing that. So we don't want that to happen. We don't want the participants to know, because we want the expectation to be there for both of them, right? In both groups where they're getting the sugar pill and they're getting the medication, we want both of them to be thinking, this is probably going to help me. Okay? And when we've made that equivalent, again, we're left with a situation where it's just medication versus not. It's the only difference between the two groups. So there's like a rigidity to this where you got to be like, it has to be this way. The reason it has to be this way is because that's what's going to let you infer on the back end that there's a causal connection between this medication and these outcomes that you care about. Does that make sense? Okay. Questions or any confusion about any of that? We're about to turn the page from experiments. All right, one more example of an experiment. I just built this in. It's from an old textbook that we use, where we randomly assign new moms to the experimental group or the control group. The point of the random assignment is to control for possible third variables like parents' level of education, parents' level of income, environment, how many other kids there might be present. And in this study, it looks like we're going to see the impact of promotional materials that emphasize the benefits of breastfeeding infants on outcomes later on, like intelligence. So the experimental group gets materials to say, here's all the reasons why breastfeeding the baby is a great idea. This other group doesn't get that. And then we measure on the back end IQ scores at age 6 for these kids and see if there's any kind of impact. You could do a variation on the study and say, you know, if somebody would approve it, I'm going to randomly assign moms to do breastfeeding versus bottle feeding and see if there's some kind of difference on the back end. I'm not sure that you'd be able to get that by the review boards where you're randomly assigning people to do one or the other like that necessarily. Final slide here on the research designs. I really like this one. It's a nice review of descriptive correlational experimental designs with respect to each of their advantages and disadvantages. So for descriptive, new research, you can do research in a natural environment. That's a naturalistic observation. Those are the advantages. The disadvantages, not much control, and you can't say anything about cause and effect, right? Correlational research. The good thing is you can look at things and see if they're related, especially things that wouldn't be ethical to manipulate. On the downside, we know about directionality and third variable problems, so we can't infer causality. Experimental designs are great because you can determine cause and effect. You've got lots of control, so you're sort of the puppet master. You kind of get to play God in your research study in your lab at SDSU. The drawback to the experimental designs is maybe what you're finding doesn't generalize to other groups necessarily, to other settings. There's a potential for extraneous variables. Again, those third variables may be creeping in and causing you some headaches. The generalizability, I think especially, is something that we emphasize a couple of times here, right? Can I generalize from my descriptive research with you guys to lots of people in the U.S. population? Well, as we talked about online on Thursday, for a lot of reasons why that's going to be hard to do. So generalizability is an issue that comes up a fair amount in different kinds of studies. All right, I want to get into reliability and validity. We've got a little more than a half hour to do this and data collection techniques and statistics. So let's talk about reliability. What we're talking about here has to do with any kind of measurements that we want to make as psychologists. So we might want to measure personality. We might want to measure intelligence. We might want to measure specific symptoms of a disorder like depression. Okay, those are all reasons why we would develop some kind of a measure. It could be a questionnaire, it could be a survey, it could be some kind of interview that we do with somebody. If we're going to ultimately develop something that is useful in a scientific way, what we develop has got to have good reliability and good validity. So let's talk about each of these. Reliability, I'm going to give you two definitions there. And if we vote it, I'm sure that most of you guys would prefer the bottom definition. It really boils actually down to one word: the consistency of a measure. So a reliable measure is one that will yield similar results on March 2nd as it yields today on February 2nd. Okay? It's going to yield consistent results, assuming that the variable that the measure is measuring is something that we expect to be consistent over like a month period of time. Okay? So the example I like to use with reliability is trying to come up with a way to measure intelligence. Okay? Let's pretend for a second we're going to work together and we're going to develop today the new SDSU IQ test. Okay? We're going to work on it together, and if it's going to yield reliable results, that means that when I give it today and I give it to a bunch of people again a month from now, their scores are going to be pretty similar. In fact, that's a specific type of reliability that we're going to revisit at least 2 or 3 more times. So let me just spell it out right here. That type of reliability is called test-retest reliability. The name basically tells you what it's about, doesn't it? Right? You test someone, and then you retest them. And what you do to quantify the reliability of that measure is you compute a correlation coefficient of their scores at time 1 on the x-axis with their scores at time 2 on the y-axis. So this person scores here at time 1. Where do we expect them to score at time 2 if it's a reliable test? Probably similarly low. This person scored really high at time 1. Probably at time 2, if it's a reliable measure, we'd expect them to score there. I'm just going to make a scatter plot of a bunch of X's here. These are observations of individuals who took the test today on February 2nd and came back and took it again on March 2nd. Okay? What are we going to compute from this? What's the thing that we talked about for correlational studies? What do we compute? They're all screaming correlation coefficient. We're going to compute a lowercase r. It's going to be the line of best fit that goes through the scatter plot, what I've just kind of mapped out right there. I will tell you that the tests that have good test-retest reliability, the measures that have good test-retest reliability for things like intelligence, they have test-retest reliability correlation coefficients of positive 0.90 and higher. Is that a big number? Yeah, what's the biggest it can get? 1, right? Positive 1.0. So when we get into the section on intelligence after test 2, right after test 2 we do a little more than a class session on intelligence and IQ testing. We're going to see IQ tests there that have test-retest reliability correlation coefficients of like positive 0.94, positive 0.95. Okay? So if our new SDSU IQ test that we developed today has good reliability, that means somebody who gets a 110, let's say, today on that IQ test, when they come back in a month, they should get about a 110. Okay? If they get a 110 today and they come back in a month and they get a 75, one of two things is going on. Either the test is what? Not reliable because there's a 35-point drop, or they sustained a massive head injury in between. That's really the only way that the scores are going to bang around that much, because IQ is pretty stable, especially over that short period of time. Okay? So everybody get the idea with reliability? We want a good measure of psychological traits that we're interested in this course to yield consistent results. Is that enough? Because I'm asking the question, the answer is probably no, right? Especially because I haven't talked about validity yet. So let me give you a scenario where we could see the limitations of a measure that has good reliability but maybe lacks good validity. Okay? So let's imagine for a second I have a bathroom scale sitting here on the floor, okay, up front. And I step on that scale, and that scale says 100 pounds. I step back off. My students are getting progressively nicer because the last several semesters, everyone just laughs when I get on and it says 100 pounds. And both the 8 and 9:30, I like you guys a lot more. Previous semesters, they would laugh and giggle and say whatever, mean things about me. Step back on the scale, it says 100 again. It's really consistent. It's really reliable, right? It's yielding consistent results. It's 100 pounds again. That's amazing. Okay, what's the problem? And say it nicely. Somebody raise a hand. What's the problem with that scale? How would you say it without getting on my bad list? What's the problem with the scale? Come on. It's calibrated wrong. Well, that's really scientific sounding. What do you know about me in terms of my weight? Is it 100? Do I weigh 100 pounds? No. Thank you for being nice and just saying no. No, we're like, pfft, right? That's not the answer when I ask that question, right? The last time I weighed 100 pounds, I was like 12. Okay, so It's reliable, but the problem is what? I like that it's not calibrated right. It's not measuring it right, right? Like it's sort of a scenario where you're like, I've got a super smart friend, and your IQ test said he's got like an IQ of 29, and like the mean is 100. That's a problem, right? The other way I think about this, what we're getting to, is validity, right? Imagine one of the items on our new SDSU IQ test to measure intelligence was we had you take a water bottle like this and throw it up in the air and catch it as many times as you could in a minute. This is awesome. I promise not to do it for a whole minute. Okay? And I said, you scored really high on the bottle tossing part of our IQ test. Is that anything about intelligence? What is that test about? Coordination, eye-hand coordination, motor skills, something like that. It's not like, I want to hire that guy because he's super smart. He threw that water bottle up and down like nobody I've ever seen. That's not how Google hires people, right? So what we're getting at here is validity, right? I'm going to give you 3 different ways of thinking about validity. You're probably going to like the bottom one best. The validity of a measure goes to the truthfulness of the measure, okay? Is it really measuring weight truthfully? It's not, okay? It sounds like it's not calibrated right. That's a really good sounding explanation, right? That doesn't sound like a truthful measure of intelligence when you had the guy throw the water bottle up and down. What the hell does that have to do with intelligence, right? I like the middle question. This is how I got it banged into my head in grad school, right? How well does my measure what I say it measures? You just like perseverate on the word measure. You just keep saying it again and again. Okay? How well does my IQ test measure intelligence? Because that's what I say it measures. Or is it maybe measuring something else? Okay? What has the DMV decided is a valid test of your driving ability? When you want to get a license, how do they test you? After you do the written test. How do they test you? You drive a car. They don't have you come in and juggle or see how nicely you could tie your shoes, or they don't have you stand there and do this. They're like, hey, we're going to have you drive a car. We think that's going to be a valid measure of your driving ability. Okay? Although the way some people drive, I think maybe they had one of those alternative tests. Okay? So is it truthfully getting at the thing that I want to get at? Right? If I gave you a valid measure of part 1 of our course in 2 weeks, it's going to have questions about behaviorism. It's going to have questions about correlations. It's going to have questions about the hippocampus and some other bio that we're going to learn pretty soon. Okay? If it's not a valid measure of what we've been learning, it's going to be a bunch of math problems. I'm going to ask you to factor some equations. I'm going to make you do like geometry proofs. And some of you are going to cry, right? Like, I don't know about this alternate interior angles. We didn't talk about that at all. What the hell is wrong with you? Right? The problem is, if I give you those questions, it's not a valid measure of what we've been doing. Okay? So validity, again, goes to how well am I measuring what I say I'm measuring. Okay? Everybody see the difference between the two? We need to have both, right? If we're developing a new intelligence test, it's got to yield consistent results. And by the way, it's got to get at intelligence. So think about that. We're going to talk about this more in part 3 of the course. Think about all the different kinds of skills and abilities you have to assess. Because intelligence is not just like how many fancy math problems can you do? How many complicated words do you know, right? But in fact, this is one of the things I put in my notes. Where online IQ tests come up short is with respect to validity, don't they? Have you ever done one of these? Right? You just Google IQ test and you start doing it, you're like, this is not intelligence, it's just a bunch of vocab. And I don't read that much, so I'm going to look like I'm not very smart. Or you do another one. My brother, who's a math professor, likes to send, take this IQ test, and it's a bunch of math problems. I'm like, dude, that's not an IQ test. That's a math test. So if it says you got like a 200 IQ, it just means you're really freaking good at math. But like if I give you a word that's more than 4 letters long, you don't know what it means. Right? It's not measuring the same thing. Okay? So we want to make sure that we're truthfully measuring the thing that we're curious about measuring. I'll give you one more example of problems with validity before we move on. Let's imagine in the depression treatment outcome study, my assessment of depression includes a ton of items about symptoms like being tired all the time, having lots of aches and pains, having low energy, and having problems sleeping. What segment of the population is probably going to say yes to a lot of those kinds of questions about being tired, aches and pains, low energy, hard time sleeping? Who complains about that a lot? The elderly, right? So you give this to people and like, all the old people have major depression. Okay? No, what has happened is you've inadvertently developed a measure that's not truthfully getting at depression because you're oversampling on these items where we know older folks are going to report more of those symptoms. Does that make sense? So a good measure of depression should kind of even out those things so it doesn't look like, oh my God, every person over age 70 has major depression. We got to give them all happy times. Right? That's how we're going to fix it. All right. So let's talk about a couple of polling questions here to practice what we've been talking about. A couple of clicker questions. Which of the following typically makes your experimental groups and control groups really similar before you do that IV manipulation? Is that random sampling, random assignment, counterbalancing, or the double-blind design? The jumping clickers have struck again. And we got two major concepts to do in our last 20 minutes. We're going to talk about data collection techniques and briefly about descriptive statistics. All right, we're looking good here. We're above 80% again. Random assignment is the correct answer choice. If people mix it up, it looks like they most often mix it up with random sampling. Remember, random sampling is how you pull the people into your study, and once they're in the study, you divvy them up via random assignment. That makes the different groups similar. What I mentioned on Thursday was random sampling makes your sample look like your population. Random assignment makes the different groups in your study look like each other. So both of them are about making pairs of groups similar. Random sampling is about sample looking like the population. Random assignment is group 1 is similar to group 2 within your study. All right, here's the 7 dwarfs question. You didn't think you were going to get one of these, but here you go. A researcher decides to measure intelligence by the number 7 dwarfs that you can name correctly. What's going on with that measure of intelligence? Is it of questionable reliability? Is it acceptable? It's just fine. Is it unacceptable due to experimenter bias? Or is it of questionable validity? So we're going to measure, we're going to quantify intelligence by the number of 7 dwarfs that you can name correctly. I got to check if my 8th grader keeled over. He's homesick, and Mom had to go do a deposition. He's going to text me if he was going to keel over. All right. I'm utterly convinced at this point that I must be teaching validity a whole lot better than I used to teach it, because this question used to screw everybody up. But it doesn't screw people up anymore. Well, other than the person who chose E. So I'm guessing that was a mistake, and I'm just screwing around. So explain to me in your own words, why is this of questionable validity? If you had to explain this to someone, D is the right choice. You had to explain it to somebody that doesn't know much about this, why is this a measure that has questionable validity? There are more than 400 of you here, and somebody needs to raise a hand. Yeah, go ahead. Okay, great. She said it doesn't really measure IQ or intelligence. It measures how well you know these characters from the Disney movie. Yes, right? So the problem here is there's one of two scenarios. You could have someone who's really, really smart but hasn't, what? Never seen this movie. They don't, or they saw it and they didn't really pay a whole lot of attention to the different names. So now we're inadvertently saying that person is not really bright, right? Or the other scenario is even funnier, right? So the person knows almost nothing. In fact, The only thing they know is the names of the 7 dwarfs. And with this test of IQ, like, this guy's a freaking genius. Have you talked to him about anything else? No, but he's got Doc and Dopey and all that nailed down. Ask him what 2 plus 2 is. Huh? What? Right? So in either scenario, you're getting at this idea of we're not truthfully measuring intelligence. Very good. For some reason, in the past, this question was something that stumped everybody, and we used to do a discussion with each other, and then we re-asked the question, but you guys are either getting smarter, or I'm getting better at teaching, or maybe both of those things are going on. All right, let's talk about, in our last 15 minutes here, some data collection techniques. We're going to talk about measuring anxiety through various different measures, through various different techniques. And to make it a little more specific, let's measure anxiety in a bunch of 16-year-old boys or young men, whatever you want to call them. Okay? And I'm doing this sample of 16-year-old boys on purpose. Okay? Why? Well, because we could ask them to tell us about their level of anxiety. We could give them, here's 50 different scenarios, situations that might make people anxious. Give us a rating from 0 to 100. 100 representing highest level of anxiety when you are faced with these different situations. So it might be public speaking, it could be spiders, it could be heights, it could be meeting someone new, it could be doing a presentation in class, whatever it is. How much anxiety do you experience in these different situations? What's the major drawback or problem with self-report measures like this? Yeah. Yeah, so these guys are probably going to, more than anything, I'm guessing you would say they're going to underreport their anxiety. They're not going to admit, like, oh, dude, I'm not afraid of anything. Right? You drop a spider on his lap and he's running for the hills. Right? So because people potentially lie and either over-report, or in this case, probably more likely under-report, we probably want to go beyond those self-report measures. Right? Because I guess what you're getting at is we're not getting a valid assessment of their level of anxiety because they're lying. Right? So we could talk to other people. This is called using multiple informants to get additional perspectives, if you will, on this individual's level of anxiety. So we're going to use informants. This is cool. So we could talk to who to get more information? Raise some hands. Who could we talk to? The teachers, parents, friends, brothers and sisters. Yeah, lots of people could play the role of another informant. And the cool thing about this is we can look to see the degree to which their ratings of anxiety correlate with each other, right? Is there any association between overall anxiety score from this 16-year-old boy's self-report and what his mom says he experiences, or his dad? Or that would be kind of an interesting study, right? To what degree do they agree about levels of anxiety? I'm betting that those correlations would be pretty small. Probably like 0.2, positive 0.3, something like that. Not a giant number. We could do direct observation. This is the part I love because it takes us back to behaviorism, old school behaviorism, right? Psychology is the science of observable behavior. So if you want to discern whether someone is anxious or not, watch them. Count behaviors that are indicators of anxiety. So I need help with this. If we're going to develop a checklist that we'll use the iPad now to click on behaviors that someone is doing that indicates they're nervous. Raise your hand. Tell me, if somebody's nervous, what are they doing? Biting their nails, okay? That's one. What else does somebody do when they're nervous? How do I know? Tapping their foot, shaking your leg. This is like during the test of 2 weeks. I see this everywhere. The legs are going crazy. They won't stay still. What else does somebody do who's nervous? Might running fingers through their hair? Playing with their fingers or with their hair. This is the thing that I've noticed more than anything during the test. The women in the class. Not that I'm weird like just watching you. It's you guys are sitting there and during the test it's this, right? You guys have seen it, right? Here it is. Twirling the hair. And I think by the time we're done, like you're going to have that 80s teased out full kind of thing going on, right? So you see a lot of that, the twirling of the hair. What else might indicate that somebody's nervous? When you get nervous, what do? You could be sweating. I'm glad you said that, not because I'm like all into sweat, but sweating brings up a perfect example to think about in terms of validity, right? Sweating could indicate that you're nervous. What else could sweating indicate? You're hot. It's like friggin' 90 degrees out. It could indicate that you just ran across campus, so physical exertion. It could indicate that you're sick, right? So contextually, we'd want to know more about what's going on with that sweating, right? So, just because the person has the sweat dripping on, they could have just eaten something really spicy, right? And that's why they're sweating. Something like that is going on. That was just in some TV show I was watching within the past week. Psychophys measures. Here we're going to measure things like heart rate and blood pressure. So HR is not home run, it's heart rate. BP is not batting practice, it's blood pressure. We can even measure something called skin conductance, which is really about sweating. Okay, so skin conductance. As a couple of examples here of psychophysiological measures where we're directly measuring these physiological changes that we think are indicators of, well, in this case, anxiety. But again, some of these things could be indicators of exertion or whatever. Okay, so keep in mind questions about validity. Let me just tell you, the take-home message here is this. The best studies are the ones that take what we call a multi-method approach to measurement. They don't rely just on sending you a URL and having you do an online survey, and that's the whole study. Okay? The best studies are ones that try to pull in lots of different sources of data, right? So if you wanted to study, student success in a course like this, you'd want to observe students in the classroom. You'd probably want to track things that they're doing on Blackboard. You'd probably want to keep track of attendance at things like supplemental instruction. You'd probably want them to track for you the number of hours that they're studying, all of those things. Okay, and none of those is just like, here, answer a bunch of questions in this online survey. It's a little bit heavier lifting, but the best studies take that kind of multi-method approach. Okay? Questions about that at all? All right, I want to take 2 minutes and do some descriptive research with the clickers about who's in the class. So real quick, I'm going to do like 15 seconds on each of these. There are no right or wrong answers, all right? You're not getting points for being male or female or whatever is going on here. Let's just run this for 15 seconds each. We could describe our class. Okay? What do we have? 2/3 female. There you go. The guys are happy about that. What's your age? Make E be 21 or older, because it only goes to E. Okay? So we have 2-to-1 ratio females to males. Okay. Let me stop this again. What's your age? Well, most of you guys are 18 or 19. So that's what we've got going on here. Let me get rid of this. We still have one more slide, so don't start packing up yet. We're not done. What year in class are you? Well, if you're 18 or 19, in terms of correlations here, most likely you're going to be freshmen and sophomores. Let's take a look. What do we get? A lot of freshmen and a few other folks. That's interesting. My 8 o'clock class is much more balanced between freshmen and sophomores than you guys are. Maybe that's because of the registration thing. You guys could get into the 9:30 and the sophomores were screwed, couldn't get into 9:30. All right. And then finally, where are you from? This is, again, not a weird stalking thing. I'm not tracking like where you live or anything. I'm always curious about the geographical breakdown. We're not done. Hold on. I still got to talk about statistics, and I'm going to ask you test questions. So what are we? 48 and 33 is 81% from California. The remaining 19% breaks down between folks who are still from the U.S. You guys actually have a smaller percentage of international students. The 8 o'clock class had 12% of folks from elsewhere. All right. Let's finish up by talking about statistics. We've got 6 minutes to do this, so we could do it easily. This is a weird graphic, isn't it? Each of these guys who's playing some weird kind of leapfrog game and then got stuck on the other dude represents one family. I just can't get rid of this. I just love this graphic. We're measuring family income, and the mean is $70,000 a year in income. The median is 30, and the mode is 20. What the heck does that mean? Well, there are 3 measures of central tendency: means, medians, and modes. What's the mean? Average. I'm assuming you know how to compute averages. Add them up and divide by the number of observations. Okay? What's the problem with means? Well, look at the mean here. This green guy here is supposed to be the typical case for family income. Does he look like the typical case? Is he where most of these families are? What's the problem with the mean? Outliers, somebody mumbled in the back. Where are my outliers here? These guys. Here's the way to describe it in your notes. The mean is not resistant to outliers. Or said in a more colloquial way, outliers screw up the mean. Okay? If I was teaching 30 students and student number 31 that I added off of the wait list, which is awesome, by the way. I know you guys hate it. I love it because no one has chased me around trying to add my class for the first 2 weeks. I used to get stalked back to my car, people trying to get in at 9:30. Let's imagine student number 31 that I add from the wait list this morning is Mark Zuckerberg. And we ask him, oh, Mark, by the way, what's your income? He's like, well, there aren't numbers that are that high. And if we put him on the chart, he'd be like in the building over there, right? And now it'd be like the mean income in this 31 student class is like $250 million a year. And you're like, I made $12 last year. Right? So it's not telling a good story in terms of what's going on with that variable. What's the median then instead? The median is the middle number when you line them up. From smallest to largest or from largest to smallest. It's the middle one, like the median on the highway splits it in two. What's the advantage of the median over the mean? What do we know about the median? When we add Zuckerberg, what happens to the median? It slides over 1. So instead of, $18 income, it goes to like $21. It doesn't get pulled. So what you can write in your notes is the median is resistant to outliers. The take-home message is going to be when you have a distribution of scores where there are outliers, really high or really low scores, what's the best measure of central tendency? The median is the best. Okay? By the way, hold on. We're not done yet. At the end of the semester, I'm going to send an email that tells you what the median course grade is. I'm not going to tell you what the mean is. You know why? Because my median usually sits at like 78 or 79 for the course. You know where my mean typically sits? Like 71. Why? Because there are outliers on the low end that are typically students who struggle on the first couple tests, and then I'll have people that don't take the last test or two. And those are zeros, right? And so I get really, really low scores that screw up the mean, and then if I sent you the mean, you're like, man, LeMakes' class is impossible. The average was a 71. Well, that doesn't really tell the story because of those low outliers. Hold on. What's the mode? It's the thing that happens most often. The mode for gender here was female. The mode for year in school was freshman, etc. It's good for those variables that are not really quantitative, right? I don't want to say that my class is filled with people who are like 2/3 female and 1/3 male, right? It's a nominal variable is a fancy term. For variability, I'm going to tell you range. I might say, I generally don't report range because I always feel like it would make the person with the lowest score feel so bad. I don't like doing it, but it's the range. The range might be from 120 to 30. It's a 90-point range. Standard deviation is the average difference from the mean. You don't ever need to compute it, but look at these two distributions. I just want you to understand that when the standard deviation is smaller, that is in the red distribution, where do most of the scores fall? Kind of compactly around the mean. Whereas the blue distribution, imagine that's the 8 o'clock class, their scores are spread out all over the place. A lot more variability in their scores. Okay? That's everything on methods. We'll start bio on Thursday online. I'll see you guys then.